What if the first people to write weren't writing down history, but trying to stop it from happening again? What if the sky they watched so carefully wasn't something wonderful, but something terrifying they had already survived once? Deep in southern Iraq, where summer heat makes the horizon look wavy, and where old riverbeds hold memories older than language itself, pieces of baked clay still carry warnings pressed into mud 5,000 years ago. Each cuneiform mark was meant to save something important. But now those warnings sit under centuries of sand and silence, waiting for someone to understand what they were really seeing. Before the story pulls you in, take a moment to like this video and hit subscribe, but only if you're interested in histories that blur the line between myth and survival. And if you're still here, tell me in the comments where you're listening from and what time it is there. I want to imagine this ancient fear stretching across the world, connecting all of us in the dark. The story begins not with a clear answer, but with confusion. In the late 1800s, British and French explorers dug into the Tels near Uruk, Lagash, and Sippar, those massive earth mounds that dot the Mesopotamian plain like burial mounds for entire worlds. Their shovels hit layer after layer of clay tablets, thousands of them, stacked in rooms that had been sealed when Rome was still a swamp and Athens was just a dream. They were the records of the Sumerians. And from the moment those tablets were translated, something disturbing appeared in the timeline of human knowledge. Because what the Sumerians left behind wasn't the clumsy astronomy of a culture learning to count stars. It was already refined, measured, and disturbingly accurate. The earliest star catalogues appear around 3500 BC with no practice phase, no crude attempts, no gradual improvement. Their Venus cycles were accurate to the day. Their eclipse predictions can be checked by modern software. Their constellation maps match the sky exactly as it appeared in their time and as it had appeared thousands of years before. It was as if the curtain had lifted on a civilization that began with its eyes already fixed on the heavens, tracking patterns that should have taken thousands of years to figure out. But they weren't just watching, they were warning. Archaeologists expected farming records and temple inventories. Instead, they found tablets describing stars that cross, stones of fire from the sky, and gods who rain destruction from above. Omen texts warned that when the red star rises in the east, famine follows. Star catalogues mark not just planetary positions, but danger seasons, times when the sky itself became a threat. These weren't poetic metaphors. They sat beside math tables, building plans, and irrigation schedules. The language was clinical, observational, urgent. One tablet recovered from the temple library at Sippar records a sequence that modern researchers still struggle to explain: a countdown of celestial events, followed by a description of the burning wind that needs no rain, and the day the horizon caught fire. It reads less like mythology and more like an eyewitness account. The clay remembers what we have forgotten. Imagine holding one of those tablets, its surface still rough with the grain of ancient Mesopotamian mud, its wedge-shaped cuts pressed deep by a reed stylus held in a hand that stopped breathing 5,000 years ago. The writing system they used, cuneiform, wasn't merely an alphabet, but a compression of meaning. Each mark carried sound, symbol, and sometimes multiple layers of interpretation. Through these marks, they recorded medicine, law, trade routes, hymns, and the movements of planets most cultures wouldn't name for another 1,000 years. One text catalogues the retrograde motion of Mars. Another describes Jupiter's 12-year cycle. A third traces the path of what they called Shatalu, the red destroyer star, with a precision that suggests they had tracked it across generations. And then there are the temples themselves. When excavators uncovered the ziggurat, they found something unexpected. Its corners align not just with the cardinal directions, but with the rising points of specific constellations: Taurus, the Pleiades, Orion's belt. Other temples pointed towards the maximum intensity points of known meteor streams. The architecture wasn't symbolic. It was functional. These weren't houses of worship. They were observatories designed to track celestial dangers. The Sumerians spoke of a time before cities, before kings, when knowledge descended from the sky. They described their earliest teachers not as human elders, but as divine figures at Kalu, the 7 sages who emerged after the waters receded and taught humanity to rebuild. Modern scholars dress this language in mythology, but the clay itself feels older than metaphor. It feels like testimony. How could a civilization emerge so suddenly with such advanced understanding? History prefers slow accumulation, one discovery building on another, tools improving little by little, knowledge passed carefully through generations. But the Sumerians disrupt that rhythm. They appear in the archaeological record already literate, already numerate, already watching the sky with an intensity that suggests prior necessity. And they weren't alone in what they remembered. When archaeologists compared Sumerian flood narratives with those from Akkadian, Hebrew, Hindu, and even Mesoamerican sources, they found the same sequence: a world-ending catastrophe, fire from the sky, darkness that lasted days, waters that consumed cities, and a handful of survivors tasked with preserving what came before. These weren't borrowed stories. They were parallel memories. How could cultures separated by oceans and thousands of years describe the same catastrophic pattern? Perhaps because the catastrophe was real. Perhaps because survival required remembering. In the Museum of the Ancient Near East in Berlin, a clay cylinder rests behind protective glass. Its surface is covered in dense cuneiform, a building dedication for a temple to Inanna, goddess of the evening star. But among the ceremonial phrases, one line stands out: this is the restoration of what was before. Restoration, not creation, not invention. The word implies inheritance, continuity, remembrance of something lost. It's a quiet admission that even the Sumerians saw themselves not as pioneers, but as inheritors of knowledge that predated them, knowledge that had survived something terrible enough to require rebuilding. And if you look closely at certain tablets, you can still see them fingerprints pressed into the wet clay before firing, the unique whorls and ridges of a scribe who lived 6,000 years ago. That person held this warning, shaped these marks, and sent them forward through time, not knowing if anyone would understand, but hoping someone would listen. Sometimes the most important part of a message isn't what it says, but what it assumes you already know. The Sumerian tablets don't explain why the sky is dangerous. They assume you remember. They don't justify the need for constant observation. They assume you understand. They record cycles, periodicities, return patterns, as if their readers already knew that certain objects come back, that certain seasons carry greater risk, that the heavens themselves follow a rhythm of threat and reprieve. That assumption, that casual familiarity with cosmic danger, is what makes the silence around these texts so heavy. At night, when the museums close and artificial light fades from the display cases, I imagine those tablets exhaling in the dark, each one holding a fragment of memory from a world we can no longer see clearly. We call the Sumerians the beginning of civilization. But maybe they were the remnant of something older, the survivors of a world that learned too late to watch the skies. And as desert winds pass over the ruins of Uruk and Eridu, carrying grains of ancient dust into another millennium, you can almost hear the question their tablets were really asking: if we survived the fire once before, how do we make sure it doesn't catch us unprepared again? So the question becomes, what were they watching for? The answer begins in the dust itself. When Leonard Woolley's expedition reached Ur in 1922, his workers had already spent weeks hauling away centuries of compacted sand. The tell, that distinctive mound shape that marks buried cities across Mesopotamia, rose nearly 60 feet above the surrounding plain. Beneath it, layer upon layer of occupation pressed down like pages in a book written in brick and ash. But it was the temple precinct that stopped him cold. The ziggur's foundation platform pointed precisely toward the heliacal rising of Sirius. Its secondary altar aligned with the Pleiades at their zenith. And carved into the threshold stones were not prayers, but coordinates, angular measurements preserved in BASC 60 notation, the same mathematical system we use today to divide circles and measure time. This wasn't decoration. It was instrumentation. Woolley wrote in his journal that night, "We did not find a temple. We found an observatory disguised as one." And he wasn't the only one noticing. Across southern Iraq, every major excavation of the 1920s and 30s revealed the same pattern. At Eridu, the oldest continuously occupied city in Sumer, 7 temples had been built one atop another. Each foundation aligned to track the precession of the equinoxes, a 26,000-year cycle that takes generations of continuous observation to detect. At Nippur, the sacred district's courtyard formed a perfect sighting instrument for tracking Venus through its 584-day cycle. These cities didn't grow organically around wells or trade routes. They were positioned according to celestial geometry, as if their locations had been chosen specifically to triangulate the sky. But it was the tablets, always the tablets, that carried the real weight. In 1924, a German expedition to Uruk uncovered a sealed chamber beneath what had been a scribal academy. Inside, over 5,000 clay documents, many still in their original wicker baskets. The majority were administrative grain tallies, labor contracts, the ordinary bureaucracy of urban life. But mixed among them were texts of a different nature entirely. One series, later catalogued as the Enuma Annual, contained 70 tablets devoted entirely to celestial omens. Not mythology, not prayers, omens. Cause and effect predictions linking sky events to earthly consequences. When the red star stands in the east, famine shall follow. If the star of crossing appears in the month of Abu, let the king fortify the city. When the star that scatters fire passes through the bull, let no man travel at night. The language was clinical, observational, stripped of poetic embellishments. These were working documents consulted by priests whose job was to forecast danger. And then there were the stranger texts, fragments that didn't fit the pattern. One tablet described the stone of the sky that fell in the time of King Ligobanta, which turned the field to glass and the river to steam. Another recorded the day the wind came without clouds, and the horizon burned though no fire was lit. A third warned of the star whose tail stretches across the heavens like a wound, bringing with it the season of dust. For decades, scholars filed these under mythology metaphor, the primitive mind's attempt to explain natural disasters through divine punishment. But then someone checked the dates. Many of these mythic events aligned with real climatological anomalies, visible in ice core data and sediment analysis. The season of dust corresponded with a documented volcanic winter. The field turned to glass matched impact melt signatures found at certain Mesopotamian sites. The day the horizon burned fit the atmospheric conditions of a major airburst. These weren't myths. They were records. Meanwhile, deep in the excavation layers, archaeologists kept finding something that contradicted everything they thought they knew about civilizational development. Sumer appeared suddenly. The earlier cities of Eridu, Uruk, Nippur all showed full urban complexity from their founding layers. No transitional phase, no gradual accumulation of knowledge. They emerged with writing systems already standardized, mathematical frameworks already sophisticated, and astronomical knowledge already precise. It was as if someone had flipped a switch. At Eridu, the first temple level dated to roughly 5400 BC, more than 1,000 years before Sumer's official beginning. Yet even this earliest structure showed celestial alignment. Even its foundation stones bore angular measurements. The knowledge didn't develop there. It was already present. One French archaeologist examining the stratigraphy at Lagash noted in his report, "We keep digging, expecting to find the beginning. Instead, we find only refinement upon refinement, as if we are excavating the end of something, not the start." And then came the Mulapin. Discovered in fragments across multiple sites and painstakingly reconstructed, the Mulapin star catalogue remains one of the most remarkable documents in ancient astronomy. It lists every major constellation visible from Mesopotamian latitudes, records their rising and setting times throughout the year, tracks the movements of the 5 visible planets, and calculates lunar intervals with startling accuracy. Modern astronomers have verified it against computer simulations of the ancient night sky. The Sumerians got it right. Not approximately, not symbolically, but correctly. But buried within the catalogue's technical precision were curious additions. Certain stars were marked with warning symbols. Specific dates were flagged as dangerous. And one entire section described what they called the path of the destroyer, a trajectory through the sky that returned when a count of years is complete. The text specified this return occurred in cycles of 60 times 60 years, 3,600 years. A periodicity that matched nothing in planetary motion, but aligned disturbingly well with certain long-period comet orbital patterns. In 1953, a young epigrapher named Samuel Kramer was cataloging tablets in the University Museum at Philadelphia when he found something that made him call his colleagues into the room. It was an omen text from Nippur, dated to approximately 2100 BC. But unlike other omens, which described past events or ongoing patterns, this one used future tense throughout. When the star of crossing returns to the path of the bull in the season when shadows are longest, let the people watch the northern sky at dawn. If fire appears without rising, destruction follows. This is written so that those who come after will know the count. The text then provided a calculation, a countdown based on astronomical cycles, that appeared to project forward more than 1,000 years from the date of writing. Kramer's note in the margin of his translation simply read, "Prophetic astronomy." But prophecy implies divination, guesswork, religious vision. This was something else entirely. This was a culture that had identified a pattern, a dangerous recurring pattern, and was trying to warn their descendants about its return. The question that haunted researchers wasn't whether the Sumerians possessed advanced astronomical knowledge. The evidence made that undeniable. The question was why. Why would humanity's first urban civilization dedicate such extraordinary effort to watching the sky? Why build temples as observatories? Why create mathematical systems specifically designed to track celestial cycles? Why preserve star catalogs across generations with such religious intensity? Unless they had a reason. Unless the sky had already proven itself dangerous. Unless they were trying to make sure it never caught them unprepared again. If these warnings were prophetic, if the Sumerians truly could predict celestial danger, then somewhere in their astronomical records, there must be evidence of what taught them to watch the sky with such intensity. And if that evidence exists, what did they witness that we have forgotten? The answer lies not in what the Sumerians believed, but in what they measured. In 1900, a Jesuit priest and mathematician named Johann Strasmayr was working through a collection of Babylonian tablets at the British Museum when he encountered something that troubled his understanding of ancient intellectual capacity. The tablet, dated to approximately 1800 BC but clearly copied from much older Sumerian sources, contained a numerical table tracking the appearances of Venus over a span of 20 years. The cycle it described 584 days from one heliacal rising to the next was accurate to within hours of modern astronomical calculation. But what unsettled Strasmayr wasn't the accuracy, it was the implication. To achieve this precision required continuous observation across multiple generations, mathematical frameworks for predicting planetary motion, and an institutional commitment to record-keeping that suggested Venus tracking wasn't academic curiosity. It was essential. The tablet didn't explain why. It simply recorded the data as if the reader already understood its importance. Other researchers began connecting similar threads. The Enuma Annual Catalog didn't just list stars. It tracked their behavior through time. It noted which constellations rose before dawn during specific months, which planets moved through retrograde motion, and which celestial events coincided with seasonal changes. But buried within these observations were patterns that had nothing to do with agriculture or calendrical management. Certain dates were marked with the Sumerian symbol for danger. Specific stellar configurations were flagged with warnings. And one occurring notation appeared throughout the time when the sky opens. Modern astronomers recognized what the Sumerians were describing: meteor showers. But not just any showers, predictable ones. The Perseids in August, the Leonids in November, and most prominently the Taurids in late October through early November, when Earth passes through a debris field so dense that ancient skies would have blazed with falling stars night after night. The Sumerians had mapped these streams with startling precision. Their temples weren't just aligned to planets and constellations. They pointed toward the radiant points of known meteor showers, the spots in the sky where shooting stars appear to originate. At Ur, the Ziggurat's northwestern corner aligned precisely with the Taurid radiant as it appeared in 3000 BC. At Eridu, sight lines carved into the temple courtyard pointed toward the same region of sky during the stream's peak intensity. At Nippur, astronomical tablets recorded the season of fire rain, with dates that matched modern calculations of when the Taurid stream was historically most active. This wasn't religious symbolism. This was targeting. But why would a civilization track meteor showers with such intensity? Most shooting stars burn up harmlessly in the upper atmosphere, creating nothing more than brief streaks of light. They're beautiful, yes, but hardly threatening. Unless the Sumerians knew something we're only now rediscovering. In the 1980s, astronomer Victor Klube and astrophysicist Bill Napier proposed what they called the coherent catastrophism hypothesis. They argued that Earth's orbit periodically carries us through regions of space containing not just dust and pebbles, but larger fragments, boulders, house-sized objects, even small asteroids, all remnants of ancient comets that have broken apart over millennia. The Taurid meteor stream, they suggested, wasn't just pretty lights. It was a debris field containing objects large enough to survive atmospheric entry, large enough to explode over cities, large enough to alter climate. And Earth passes through it twice every year. Most years we encounter only the diffuse edges, thousands of harmless meteors, nothing more. But every few centuries, our orbit carries us through denser concentrations. And every few thousand years, we pass through regions where the truly dangerous fragments lurk. When Klube and Napier mapped the most destructive airbursts in recorded history, Tunguska in 1908, Chelyabinsk in 2013, and probable ancient impacts inferred from geological evidence, they found a pattern. Many occurred during Earth's passage through the Taurid streamer's associated debris clouds. The Sumerians, it seemed, had been tracking the same threat. Their tablets recorded what they called the Bull of Heaven, the constellation Taurus, home to the Pleiades cluster, and the precise region of sky from which the Taurid meteors appeared to radiate. But the Sumerians didn't describe it with reverence. They described it with fear. One text warns, when Mul rises with the sun, let the watchman stand ready. When the bull crosses the path of the wandering stars, destruction walks with light feet. Another tablet, discovered at Lagash in the 1930s, contained calculations that baffled translators for decades. It described the star of crossing using a numerical sequence that didn't match any known planetary orbit. The cycle repeated every 3,600 years, far too long for any visible planet, yet precise enough to suggest actual observation, rather than mythological invention. In 2007, a team of Czech astronomers ran computer simulations of the Taurid stream's evolution over the past 10,000 years. They discovered that its density fluctuates on long periodicity cycles of increased and decreased risk, driven by gravitational perturbations from Jupiter and Saturn. One of those cycles matched the Sumerian 3,600-year count almost exactly. The implications settled like cold stone. The Sumerians weren't predicting astrology. They were predicting impact risk windows, times when Earth's orbit would carry us through the most dangerous regions of an ancient debris field they had somehow learned to track. But how? How could a Bronze Age civilization identify orbital periodicities that required understanding gravitational mechanics, three-dimensional celestial motion, and mathematical modeling across millennia? The only logical answer was one that scholars resisted for decades. They inherited the knowledge. The Sumerian texts themselves hint at this. They spoke of the Apkallu, 7 sages who appeared after the Great Waters, and taught humanity to rebuild. They described a time before the cities when knowledge was given, not discovered. They used phrases like the old count and the counting from before, as if their astronomical frameworks predated their own civilization. And when researchers examined the earliest Sumerian astronomical texts more carefully, they found something extraordinary. The star positions recorded in the oldest tablets didn't match the sky as it appeared in 3500 BC. They matched the sky as it appeared around 10,800 BC, the end of the last ice age. Someone had been watching the heavens for far longer than recorded history suggested. Someone had tracked these cycles through catastrophe and collapse. And the Sumerians had inherited their warnings. Among the tablets, certain objects appeared repeatedly under different names, but consistent descriptions: returning stars, crossing stars, stars that bring heat, the destroyer that comes in seasons. Modern astronomy has now identified the real objects these descriptions likely represent. Comet Encke, a short-period comet that orbits the Sun every 3.3 years and is the parent body of the Taurid meteor stream. The Taurid debris field itself, a vast cloud of cometary fragments Earth passes through annually. Possible remnants of the Younger Dryas impacts swarm the objects that may have triggered the catastrophic return to Ice Age conditions 12,800 years ago. And other unidentified objects still hidden in the stream's denser regions, waiting for the orbital mechanics that will one day bring us face-to-face with them again. The Sumerians had given these objects names Shatalu, Nibiru, Lugalmal. They had tracked their returns. They had calculated their danger periods. They had built temples to watch for them, and created priestly orders whose sole function was to maintain the count. Not because the sky was holy. Because the sky was dangerous. Why would the world's first civilization dedicate such extraordinary resources to tracking destructive objects, unless their ancestors had already seen one strike? Unless the memory of fire falling from heaven wasn't myth, but history they refused to forget. The evidence is written in the earth itself. In 2007, a team of geologists led by Richard Firestone published findings that would fundamentally challenge our understanding of human prehistory. They had been analyzing sediment cores from dozens of sites across North America, Europe, and the Middle East layers of Earth that recorded the environmental conditions of the late Pleistocene epoch, the final chapter of the last ice age. What they found in a thin black boundary layer dated to approximately 10,800 BC stopped them cold. Nanodiamonds, microscopic carbon structures that form only under extreme pressure and heat, the kind generated by cosmic impacts or nuclear detonations. Magnetic spherules, tiny balls of molten rock flash frozen in midair. Iridium concentrations, the telltale signature of extraterrestrial material. And a carbon-rich mat containing the charred remains of what appeared to be continent-wide wildfires. The layer appeared across multiple continents, always at the same depth, always with the same composition. Something catastrophic had happened to Earth 12,800 years ago, something sudden, violent, and global. They called it the Younger Dryas impact event. The climate record shows what followed with brutal clarity. Within decades, global temperatures plunged. Ice sheets that had been retreating suddenly surged forward again. Entire ecosystems collapsed. The megafauna that had survived hundreds of thousands of years of ice age fluctuation, mammoths, saber-toothed cats, giant ground sloths, went extinct within centuries. And the emerging human civilizations of the Near East, those early settlements that were just beginning to experiment with agriculture and permanent architecture, vanished from the archaeological record for over 1,000 years. The world had been reset. But not everyone forgot. When researchers began examining the distribution of impact proxies, those geological markers of cosmic catastrophe, they found concentrations across the Fertile Crescent, the very region where Sumerian civilization would later emerge. Sites in Syria, Turkey, Iraq, and Iran all showed evidence of high-temperature events, mud glass formations, shock quartz, and sediment layers indicating sudden intense heat. One site in particular drew attention. Abu Hurair, a settlement in northern Syria, showed a distinct burn layer dated to the Younger Dryas boundary. The layer contained glass-like carbon formations and melted building materials temperatures, far exceeding anything a normal fire could generate. When researchers analyzed the directional patterning of the melted material, they found it consistent with a massive airburst, the kind that occurs when a large meteor explodes in the atmosphere. Before reaching the ground, the blast would have flattened everything for dozens of miles. The thermal pulse would have ignited fires across hundreds of square miles. The shock wave would have been felt across the entire region. And if anyone survived to witness it, they would never forget what they saw. The question became, did those memories survive long enough to reach the Sumerians? Archaeological evidence suggests they did. The oldest layers of Sumerian cities, those mysterious foundations that appeared suddenly with sophisticated knowledge already intact, sit atop earlier settlement remains showing signs of catastrophic abandonment. Between the pre-Younger Dryas occupations and the Sumerian rebuilding lies a dark period: sparse populations, minimal construction, a world in survival mode. But when the cities re-emerged, they emerged with an obsession. They watched the sky. Yet the Younger Dryas wasn't the only impact event that shaped the ancient Near East. In the late 1990s, paleoclimatologist Harvey Weiss was studying the collapse of the Akkadian Empire, the powerful state that arose after Sumer and briefly unified Mesopotamia under a single ruler. The empire had flourished for over a century, then vanished with shocking suddenness around 2200 BC. The traditional explanation blamed internal political collapse or military invasion. But Weiss found something else in the sediment cores from the region, a massive dust event. Around 2200 BC, soil samples from across the Middle East showed a sudden spike in atmospheric dust, chemical signatures indicating drought conditions, and evidence of rapid social collapse. Agricultural settlements were abandoned. Cities shrank. Trade networks disintegrated. This was the 4.2 kiloyear event, a climate catastrophe so severe it left marks in geological records from Greenland to Africa. But what caused it? Some researchers pointed to volcanic eruptions or shifts in ocean currents. Others noted the timing coincided with known meteor shower intensification periods. And when they examined certain archaeological sites more closely, they found the same proxies that mark the Younger Dryas spherules, null glass, and evidence of extreme heat events. The possibility emerged that the 4.2 Kali-year event wasn't just drought. It included impacts, airbursts, and atmospheric dust loading from cosmic sources. And the Sumerian tablets had recorded it. Texts from that period described the day the sun was covered, years without harvest, the wind that carried no rain, but darkened the sky for seasons. One Omen tablet warns, when the star of crossing appears in the month of Abu, famine follows for 7 years. The dating matched. The descriptions matched. Even the 7-year duration aligned with climate proxy data showing prolonged cooling after the initial shock. Then there was the 3.2 Kali-year event around 1200 BC, another global collapse that destroyed Bronze Age civilizations across the Mediterranean and Near East. Cities burned. Empires fell. Populations migrated in massive waves seeking survival. Again, the sediment showed dust. Again, the climate record showed sudden cooling. And again, certain researchers found evidence suggesting cosmic impact contributed to the catastrophe. The pattern was emerging not of random disasters, but of recurring ones, spaced by centuries or millennia, always leaving the same signatures, always remembered in myth. Because the myths themselves preserved the pattern. When scholars compared creation and destruction narratives from across the ancient world, they found remarkable consistency in the details. The Sumerian Eridu Genesis describes the sky raining fire, and the land covered in darkness before the Great Flood. The Egyptian destruction of mankind tells of the goddess Sekhmet bringing burning wind from the heavens that nearly destroys humanity. The Hittite song of Alakumi speaks of stone falling from the sky and the earth shaking. For 7 days. These weren't poetic variations on a theme. They were describing the same sequence of events: atmospheric entry, thermal pulse, shockwave, prolonged darkness from atmospheric dust, climate collapse, flooding as weather patterns shifted. It was the impact signature. And when researchers mapped the geographic distribution of these myths, they found they clustered precisely in regions showing geological evidence of impact events: the Middle East, the Mediterranean basin, and the Fertile Crescent. The stories weren't invented. They were transmitted. Generation after generation, the survivors passed down what they had witnessed. The temples preserved the observations. The priests maintained accounts. And eventually the Sumerians inherited the complete archive: the knowledge that the sky could betray you, the understanding that certain patterns repeated, and the mathematical frameworks needed to predict when the danger might return. In 2013, researchers analyzing ice cores from Greenland found microscopic fragments of extraterrestrial material distributed through layers corresponding to known historical catastrophes. The fragments showed the chemical signature of the torrid meteor stream, the same debris field the Sumerians had tracked so carefully. The impacts weren't theoretical. They weren't symbolic. They were real, recurring, and predictable enough that an ancient civilization had dedicated its entire astronomical infrastructure to watching for them. The geological record and the mythological record weren't contradicting each other. They were confirming the same terrible truth: Earth periodically passes through regions of space where the risk of catastrophic impact increases dramatically. And the Sumerians knew it because their ancestors had lived through it. If the Sumerians inherited memories of past impacts, did they also inherit instructions on how to watch for the next one? And if those instructions survived in their tablets, if the calculations, the danger periods, the celestial markers are all still there, preserved in clay, what exactly were they trying to tell us about the cycle we might be living in right now? The answer lies in the tablets themselves. In 1881, British archaeologist Hormizd Rassam discovered something extraordinary beneath the ruins of the Temple of Shamash in Nippur. The chamber had been sealed deliberately, not abandoned in haste, but carefully closed, as if someone wanted to preserve what lay inside for a time when it would be needed again. Inside were thousands of tablets, many belonging to a series known as Enuma Elish, the longest and most comprehensive omen collection from the ancient world. The series eventually grew to 70 tablets covering every conceivable celestial event: eclipses, planetary conjunctions, meteor appearances, unusual cloud formations, and atmospheric phenomena. For decades, scholars treated them as superstition, the primitive mind's attempt to find meaning in random sky events. Omens were literary devices, they argued, not scientific observations. But then someone actually tested that assumption. In 2003, a team of astronomers and Assyriologists led by John Steele at Durham University began running statistical analyses on the celestial events described in Enuma Elish. They cross-referenced the tablet predictions with computer simulations of the ancient sky, looking for correlations between predicted events and actual astronomical occurrences. What they found unsettled conventional wisdom. The correlations weren't random. The omens corresponding to eclipse predictions matched real eclipse cycles with startling accuracy. The tablets describing planetary movements aligned with actual retrograde periods. And most surprisingly, the warnings about dangerous stars and fire from heaven corresponded precisely with peak periods of known meteor streams. These weren't literary inventions. They were working predictions based on centuries of accumulated observation. But it was the language itself that revealed something deeper. The tablets didn't describe celestial events with the vague poetry of myth. They used technical terminology, precise angular measurements, seasonal markers, and duration counts. One section describes a star whose path crosses 7 divisions of the sky in the month of Tishri, bringing with it the season of dust and the failure of grain. When researchers calculated what object could cross 7 celestial divisions, roughly 70 degrees of sky in a single month, only one possibility fit a comet on a specific type of orbit, one that brought it close to Earth during autumn. The Sumerians weren't describing gods. They were describing orbital mechanics. The Molopin catalog revealed even more. This compendium, whose oldest copies dated to around 1000 BC but clearly derived from much earlier sources, didn't just list constellations. It tracked periodicities. It noted which celestial bodies returned in predictable cycles, and which ones appeared irregularly. It marked certain stars with a symbol which translators eventually realized meant dangerous or destructive. Every star marked with that symbol corresponded to a radiant point for a major meteor stream. The Pleiades marked dangerous during late October and early November, precisely when the torrid stream peaks. The constellation Mulmul, the star cluster flagged as threatening during seasons when Earth passes through dense debris regions. Alpha Tauri noted as the red star that brings famine, visible during known climate anomaly periods. These weren't mythological associations. They were hazard warnings. But the most unsettling discoveries came from a subset of tablets that scholars had filed under unclear purpose for over a century. One series from Nippur contained detailed descriptions of what the scribes called Lugalmul, the Lord of Destruction. The tablets described this object with unusual specificity. The Star of Destruction, whose tail burns like copper, whose path bends across the bull, whose return marks the count of generations. For years, researchers assumed this was a mythological figure, perhaps a war god or demon. But when they examined the descriptive language more carefully, they realized it matched nothing in Mesopotamian mythology. It matched a comet. The tail that burns like copper described the characteristic orange-red glow of ionized sodium in a comet's coma. The path that bends referenced the curved trajectory comets trace across the sky as they round the sun. And the bull was Taurus, the exact constellation associated with the torrid meteor stream. The tablet went on to provide calculations, a series of numbers describing orbital periods, conjunction intervals, and return cycles. When astronomers converted these from BASC 60 Sumerian notation to modern values, they discovered something extraordinary. The calculations described the orbital period of Comet Encke, the parent body of the torrid stream, with less than a 1% margin of error. The Bronze Age scribe had documented the orbital mechanics of a specific comet with near-modern precision. But how? The only logical explanation was observational inheritance. Someone, somewhere, had tracked this object across multiple returns spanning centuries or millennia, and that knowledge had been preserved and passed down until it reached the scribal academies of Sumer. Then in 2007, a graduate student named Sarah Cowie was cataloging fragments from the British Museum's Nippur collection when she found something that had been misfiled as an administrative document. It was an omen text, but unlike any other. Most omen tablets used past or present tense. When the red star appeared, famine followed. This tablet used exclusively future tense. When the star of crossing returns to the path of the bull in the year when 3 kings have fallen, destruction shall walk the earth. The tablet then provided a chronological calculation, a countdown based on lunar cycles, solar years, and the precessional cycle of the equinoxes. When Cowie worked through the mathematics with the help of astronomical consultants, they realized the tablet was projecting forward approximately 1800 years from the date of its composition. It was a prediction, not a record. And the celestial configuration, it described the alignment of Venus with the Pleiades during a specific lunar node, while Earth passed through the torrid stream would have represented a maximum risk scenario, when multiple danger factors converged simultaneously. The scribes were attempting to forecast an impact window nearly 2 millennia into their future. Other predictive texts emerged from museum collections once researchers knew what to look for. A tablet from Uruk described the season when fire shall return in the count, when the king of Akkad rules no more. Reference, the dated the prediction to sometime after the Akkadian collapse in 2200 BC. Another from Nippur warned of the burning wind that comes without clouds in the generation, when the sea drinks the cities. These weren't vague prophecies. There were specific predictions tied to astronomical calculations and historical chronologies. But the most chilling text came from a fragment discovered in the University of Pennsylvania's archives, overlooked for decades because its condition made translation difficult. When finally deciphered, it read, "This is written for those who come after. When the count reaches its completion, when the star of crossing returns to the place of beginning, watch the sky at dawn in the season of dying light. If fire appears where no fire should be, know that the time of warning has ended. What follows cannot be turned aside, only survived. Let those who read these words prepare as our fathers prepared, as their fathers prepared, before the waters rose." The text ended with a numerical sequence, another countdown, another calculation pointing forward through time. When researchers calculated what year that countdown projected to, accounting for calendrical differences and precessional drift, they arrived at a range that made them pause. The projection fell within the current millennium. How could a Bronze Age scribe predict a celestial danger centuries or millennia ahead? Unless what we've been calling predictions were never prophecies at all, but warnings based on observed cycles that ancient astronomers had tracked across timescales, we can barely imagine patterns they recognize, because they had witnessed their consequences before, calculations they preserved in clay because they understood with terrible clarity that the sky's betrayal was never a question of if, only when. But knowledge without application is just history. The Sumerians didn't merely record these cycles. They organized their entire society around monitoring them. In 1922, when Leonard Woolley first mapped the temple complex at Ur, he noticed something peculiar about the ziggurats architecture. The structure had been rebuilt multiple times across centuries, yet each iteration preserved the same angular relationships. The corridors pointed to identical celestial references. The stairways aligned with the same horizon markers. It wasn't religious conservatism. It was functional necessity. The ziggurat wasn't primarily a place of worship. It was an observation platform. From the summit, priests could track the rising and setting points of key celestial objects across the full horizon. Sidelines carved into the platform edges marked the positions where dangerous constellations first appeared at dawn. Notches in the walls framed specific portions of sky where meteor radiance would become visible. The temple of Nana, the moon god, sat at the ziggurat's base with its entrance facing precisely 13 degrees north of east, not toward any cardinal direction, but toward the northernmost moonrise during the 18.6-year lunar standstill cycle, when the moon reaches its maximum declination and tidal forces peak. These weren't aesthetic choices. They were instruments. Other temple complexes revealed the same pattern. At Eridu, the earliest Sumerian city, 7 temples had been built one atop another, spanning nearly 2 millennia. Archaeologists initially interpreted this as religious tradition rebuilding sacred space on sacred ground. But when astronomer Edwin Krupp analyzed the alignments in the 1990s, he discovered each rebuild had slightly adjusted the orientation to account for precession, the slow wobble of Earth's axis that shifts the apparent positions of stars over centuries. Someone was maintaining calibration. The temple of Enki at Eridu pointed toward the heliacal rising of Sirius in 5000 BC. By 3000 BC, precession had shifted Sirius's rising point by nearly 2 degrees. The next temple rebuild corrected for this drift, reorienting to track Sirius's new position. The priests weren't preserving tradition. They were updating equipment. And it wasn't just the architecture. The rituals themselves encoded astronomical timing. The Akitu festival, Sumer's most important religious ceremony, occurred during the spring equinox, when day and night balanced. But buried in the ritual texts were curious details that didn't fit spiritual interpretation. The ceremony lasted precisely 11 days. During that time, priests were required to perform observations at dawn, midday, sunset, and midnight. They recorded the positions of Venus, Mars, Jupiter, and the Moon. They noted the appearance of any unexpected lights in the sky. And on the final night, they maintained an all-night vigil, specifically watching the eastern horizon between the constellations of Taurus and Aries, the exact region of sky where the Taurid meteor stream radiates. The timing wasn't arbitrary either. The spring equinox marked when Earth's orbit began carrying it toward the daytime Taurid stream, the portion of the debris field we encounter in late June and early July, though less densely than the autumn stream. The festival wasn't celebrating spring. It was marking the beginning of elevated risk season. Other festivals followed the same pattern. The autumnal ceremonies at Uruk occurred during late October, precisely when the Taurid stream reaches maximum intensity. The lunar festivals tracked eclipse danger periods. The Feast of Fire corresponded with the Perseid meteor shower peak. What scholars had interpreted as agricultural timing or seasonal celebration was actually a skywatch calendar, a civilization-wide early warning system disguised as religious obligation. But perhaps most revealing was the priesthood itself. Sumerian priests weren't chosen for spiritual devotion. They were selected for mathematical ability and trained in astronomical observation. Scribal schools taught geometry, calculation, and celestial mechanics alongside mythology and ritual. The curriculum included detailed instruction on identifying different types of meteors, distinguishing planets from stars, and calculating orbital periods. Priesthood was an apprenticeship in applied astronomy. And the mythology they taught wasn't arbitrary either. When researchers began analyzing the characteristics and stories of Sumerian gods, they found something unsettling. Each major deity corresponded not to human virtues or natural forces, but to specific celestial threats. Enlil, Lord of the Air, wasn't a wind god. He was the personification of atmospheric shockwaves. His myths described him bringing the wind that flattens cities, the storm without rain, the breath that darkens the sun. These weren't metaphors for weather. They were descriptions of airburst events, the explosive detonation of meteors in the atmosphere that generate supersonic shockwaves, capable of leveling buildings miles from the impact site. Nergal, ruler of the underworld, governed not death, but fire from below, the superheated destruction associated with impacts. His symbol was the scorched earth. His sacred animal was the lion, representing consuming flame. And his festivals occurred during seasons when impact risks statistically increased. Inanna, goddess of love and war, was associated with Venus, but not Venus the romantic evening star. She was linked to Venus's dangerous apparitions times, when its orbit brought it visually close to the torrid radiant, creating maximum risk alignments. Her dual nature, beauty and violence, encoded the understanding that Venus's position could indicate either safety or threat, depending on its relationship to other celestial markers. Even the creation myths contained astronomical encoding. The Enuma Elish, Babylon's creation epic derived from Sumerian sources, describes Marduk destroying Tiamat by shooting arrows that split her body. Modern readers see mythology, but the text provides technical details. Tiamat scattered her fragments across the heavens, creating the band that circles the sky. It's describing the formation of a debris field, an asteroid or comet breaking apart into the stream of fragments that Earth would periodically encounter. The religion wasn't explaining where humans came from. It was explaining where the danger came from. And maintaining that knowledge required infrastructure. At Nippur, archaeologists discovered what they initially called a library, a building containing thousands of tablets organized by subject. But when they analyzed the contents more carefully, they realized it functioned more like a data archive. Tablets recorded nightly observations going back centuries. Others contained calculations updating previous predictions based on new data. Some showed corrections to earlier models, tracking how well predictions had matched reality. It was a research institution. The priests weren't just watching the sky. They were running a multi-generational scientific program designed to refine impact prediction models across timescales longer than individual human lifetimes. And they took their responsibility with deadly seriousness. Tablets from Nippur described the punishment for priests who failed to maintain proper watch during designated danger periods: exile, property confiscation, sometimes execution. Other texts outlined the protocol for reporting unusual celestial events, who to notify, how quickly warnings should spread, what preparations civilian authorities should undertake. The society had built an entire bureaucratic system around celestial threat monitoring. But perhaps the most telling detail came from texts describing the training of young priests. One instructional tablet explained, "You do not learn these counts for the glory of knowing. You learn them because your grandfather's grandfather watched, and his grandfather before him, and someday your grandson's grandson must watch in your place. The sky forgets nothing. We must forget nothing." It was a civilizational memory system, a way of preserving crucial knowledge across the generational gaps that would otherwise erase it. The rituals kept people watching. The mythology made the danger memorable. The priesthood ensured the technical knowledge survived political changes and cultural shifts. They had created an institution designed to outlast any individual ruler, dynasty, or even empire, because the threat they monitored operated on timescales far longer than human power structures. If their rituals were warnings disguised as worship, if their temples were observatories disguised as sacred space, if their entire religious system was actually a survival mechanism encoded in spiritual language to ensure its preservation across millennia, who were they trying to protect? And more urgently, who do those warnings reach across the silence of 5,000 years to protect now? The answer requires understanding what the Sumerians called Nibiru, the crossing star. For decades, this term existed at the uncomfortable intersection of legitimate scholarship and fringe speculation. Popular writers claimed it referred to a hidden planet on a collision course with Earth. Serious academics dismissed it as mythology with no astronomical basis. But neither group had looked carefully at what the tablets actually said. When linguist Sacharias Sitchin popularized the Nibiru concept in the 1970s, he translated it as planet of the crossing, and built elaborate theories around it. Mainstream scholars rightly criticized his methodology, but in rejecting his interpretation, they stopped examining the original texts closely. It wasn't until the 1990s that a new generation of researchers returned to the source material with fresh eyes. The Sumerian word Nibiru derives from Nebu, to cross or traverse, but the texts never called it a planet. They described it as Kakabu's star, or more precisely, any bright celestial object that wasn't the sun or moon. Context mattered. And when researchers analyzed every appearance of Nibiru in astronomical texts, they found it wasn't a single object at all. It was a phenomenon. The tablets described Nibiru as the star that crosses the paths, the herald that appears in seasons, the object whose return marks the count. Different texts gave it different positions, sometimes in Taurus, sometimes in Cancer, sometimes spanning multiple constellations. One text described it as the star that scatters smaller stars in its path. It wasn't a planet. It was a meteor stream. And when researchers identified which stream the Sumerians were describing, the entire puzzle shifted into focus. In 1983, astronomers Victor Klube and Bill Napier published a paper that would fundamentally change our understanding of cosmic threat. They argued that Earth's orbit carries us twice yearly through the Taurid meteor stream, a vast debris field created by the fragmentation of a giant comet approximately 20,000 to 30,000 years ago. Most years we encounter only the dispersed edges, beautiful meteor showers, harmless streaks of light burning up 60 miles above the surface. But the debris isn't evenly distributed. Gravitational perturbations from Jupiter and Saturn create dense nodes, regions where fragments cluster together, including objects large enough to survive atmospheric entry. Earth's orbit occasionally carries us through these nodes. When that happens, we don't see pretty meteor showers. We experience what the Russians experienced in 1908 over Tunguska, a massive airburst that flattened 800 square miles of forest with the force of a 50 megaton explosion. Or what witnesses described in Chelyabinsk in 2013, when a meteor exploded over the city with 30 times the energy of the Hiroshima bomb, shattering windows across 6 cities and injuring over 1,600 people. Both events occurred when Earth passed through the Taurid stream. The stream's debris field is enormous. Earth takes weeks to pass through it completely. We encounter it twice per year, the daytime Taurids in late June through early July, and the nighttime Taurids in late October through early November. The autumn stream is denser, more dangerous, and perfectly positioned for ancient observers to watch. Its radiant point, the spot in the sky where meteors appear to originate, lies in the constellation Taurus, between the Pleiades and the bright red star Aldebaran, exactly where the Sumerian text said to watch for Nippur. When researchers began comparing Sumerian celestial descriptions with modern knowledge of the Taurid stream, the parallels became undeniable. The tablets described the season when the bull brings fire, late October, when the Taurid stream peaks. They warned of a star that scatters smaller stars, an accurate description of a meteor radiance. They noted this phenomenon returns when the count is complete, referring not to a single orbit, but to cycles of increased density within the stream. And most tellingly, they tracked it with the same constellations modern astronomy uses to map the Taurid complex: Taurus, the Pleiades, and Orion, the exact region of sky the debris field occupies. But the Sumerians understood something that modern science only recently rediscovered: the Taurid stream's danger isn't constant. It fluctuates in multi-century and multi-millennial cycles. In 2015, a team of Czech astronomers led by Pavel Spurný published research modeling the Taurid stream's structure and density variations over the past 10,000 years. Using gravitational simulation and orbital mechanics, they discovered the stream undergoes periodic intensification times when Earth's orbit intersects with denser concentrations of debris. These intensification periods occur roughly every 2,500 to 3,000 years, driven by Jupiter's gravity pulling fragments into more compact orbits. During these windows, impact risk increases by orders of magnitude. Small airbursts become likely. Large airbursts become possible. Civilization-altering events become statistically probable. The research team identified several historical periods of likely Taurid intensification: around 10,800 BC, the Younger Dryas boundary, around 4,200 BC, early Bronze Age climate disruption, around 2,200 BC, the 4.2 kiloyear event and Akkadian collapse, and projected forward within the current millennium. When archaeoastronomers compared these dates with Sumerian cycle calculations, something remarkable emerged. The 3,600-year period repeatedly mentioned in astronomical texts wasn't the orbit of a planet. It was approximately the interval between major Taurid intensification peaks, the return the Sumerians were tracking. The mathematics weren't perfect, but they were close enough to suggest the Sumerians had identified the pattern through observational astronomy across many generations. They knew the danger came in cycles. They knew when Earth was most vulnerable. And they built their entire skywatching infrastructure around monitoring those windows. But the Taurid stream posed another problem that made it particularly terrifying to ancient observers: visibility. Unlike asteroid threats that approach from random directions, the Taurid debris travels in roughly the same orbital path as Earth. That means dangerous fragments approach from the direction of the sun during the daytime stream, or from the twilight sky during the nighttime stream directions, where they're difficult to detect until the final moments before impact. The Sumerians understood this. Their warning texts repeatedly emphasize watching at dawn, and in the dying light, the precise times when Taurid objects would become visible against the brightening or darkening sky. They weren't being poetic. They were giving practical observation instructions. One tablet from Europe provides detailed guidance. When the bull rises with the sun in the month of Samna, let the watchman stand ready at dawn. If fire appears in the eastern sky before the sun, if light crosses without sound, let the alarm be given immediately. What comes will arrive swiftly. It's describing the visual signature of an incoming meteor: brightness without sound, which arrives later due to the speed difference between light and sound waves, appearing at dawn from the east, during late October or early November, Samna in the Sumerian calendar, when the Taurid radiant rises with the sun. This is threat assessment protocol, not mythology. Modern research has confirmed the Taurid stream contains objects large enough to pose genuine civilizational threats. In 2019, NASA's Atlas survey identified multiple asteroids within the Taurid complex, measuring between 200 to 400 meters in diameter, large enough that atmospheric impact would release energy equivalent to hundreds of megatons, capable of devastating entire regions. These objects exist in orbits that periodically bring them close to Earth's path. Most passes are safe, but orbital mechanics are never perfectly stable. Close encounters with planets, gravitational perturbations, and collisions within the debris field itself can nudge fragments into intersecting trajectories. The Taurids are not a theoretical threat. They're a confirmed hazard with a documented history of impacts, and a future schedule of close encounters already mapped by modern astronomy. And the Sumerians knew. When researchers compiled all the Taurid-related references from Sumerian tablets and mapped them against modern understanding of the stream structure, density variations, and impact history, they found the ancient texts had preserved remarkably accurate knowledge. The correct seasonal timing, late October, early November for maximum danger. The correct celestial location, Taurus constellation, between the Pleiades and Aldebaran. The correct phenomenology, media radiance, multiple objects, varying intensities. The correct periodicity, intensification cycles measured in millennia. And most disturbingly, the correct threat assessment, civilization ending potential during peak periods. This wasn't lucky guessing. It was systematic observation maintained across timescales that dwarf modern scientific institutions. But one question remained: how did they achieve such precision? The answer appears to lie in something modern astronomy takes for granted: continuous observation spanning multiple cycles. The Sumerians didn't just watch the sky for a few generations. Their astronomical records show evidence of data collection spanning thousands of years, incorporating observations that predated their civilization by millennia. They inherited a dataset. Someone before them, the survivors of the Younger Dryas impacts perhaps, or an even earlier group, had recognized the pattern and begun recording it. Those records survived the catastrophes, were preserved through the dark periods, and eventually reached the Sumerian scribes who continued the work. The tablets weren't the beginning of the observation program. They were the middle chapters of a much longer story. And that story pointed forward as urgently as it looked back. If the Sumerians recognized a pattern, if they tracked the cycles of increased danger, if they calculated when Earth's orbit would next carry us through the densest regions of the Taurid stream, did they also see when the next dangerous cycle would return? And if their calculations survived in clay, preserved through empires and millennia, pointing toward a future they could only imagine, what did those calculations say about the cycle we're living through right now? The answer lies hidden in the language itself. In 1956, linguist Samuel Noah Kramer published what would become the standard Sumerian English dictionary, the culmination of decades spent decoding the world's oldest written language. But even Kramer noted something peculiar in his introduction: certain Sumerian terms possessed what he called suspicious precision, words that seemed too specific, too technical for their supposed mythological context. Take the word gal, typically translated as great heaven or celestial sign. But when Kramer examined its usage across different tablet types, he found it appeared exclusively in astronomical texts describing dangerous phenomena, never in religious hymns or literary works. The term combined in sky, ta, from, and gal, to exist, approach literally, that which exists approaching from the sky. It wasn't poetic language. It was threat classification terminology. Other terms revealed similar patterns. The Sumerian word yuta.ar, conventionally translated as storm, appeared in contexts where weather made no sense. Tablets described yuta.ar events that needed no clouds, that brought fire without lightning, that flattened cities, but left the river undisturbed. When linguists analyzed the component parts, they found light, day, heat, power, force, and Arkansas, to cut, to break, literally, the breaking force of heat and light. It was describing atmospheric explosions, the signature phenomenon of meteor airbursts. The language wasn't metaphorical. It was diagnostic. Throughout the 2000s, a new generation of researchers began applying computational linguistics to Sumerian texts, analyzing word frequency, contextual clustering, and semantic relationships. What emerged was startling: the Sumerians possessed an entire technical vocabulary for celestial threats that modern translators had been rendering as mythological imagery. Mul.gir.tab, the star that strikes, previously Scorpion constellation. Im.hul.sa, Grav, the wind that brings dust darkness, previously evil wind. And Ahi.gal, stone that falls, meteorite, but with specific contextual usage distinguishing it from normal stones. And .gul.la, the brightness emerging from the sky, atmospheric entry flash. Each term had precise usage rules. Each appeared in specific predictive contexts. Together they formed what one linguist called a taxonomy of cosmic disaster, a systematic classification system for different types of celestial threats and their observable characteristics. But the most revealing discoveries came from analyzing parallel text tablets where the same events were recorded in both Sumerian and later Akkadian. When the Akkadian Empire absorbed Sumer, scribes translated many older texts into Akkadian, the Semitic language that would dominate Mesopotamia for the next 2 millennia. These translations provided a crucial bridge, allowing researchers to verify Sumerian meanings against Akkadian interpretations created by people who still understood the original context. One such parallel text, discovered at Sippar, described what Sumerian called mi.sar.tam, the sky evil sweep. The Akkadian translation rendered it as Esrulem Nusaim, the evil wind from heaven that brings famine through darkness. The Akkadian version was explicit. This wasn't divine punishment or natural weather. It was an atmospheric phenomenon that blocks sunlight, causing crop failure. The text went on to describe the duration, multiple seasons, the appearance of the sky, reddish gray, and the subsequent climate effects, cold despite summer, delayed spring. It was describing impact winter, the global cooling that occurs when atmospheric dust from impacts blocks solar radiation. Other parallel texts revealed the same pattern. What translators had rendered as mythological sky battles or divine conflicts were technical descriptions of visible meteor activity, with Akkadian versions explicitly noting the agricultural and climatic consequences. The scribes weren't creating mythology. They were documenting environmental catastrophes linked to celestial events, using specialized vocabulary that preserved precise observational detail across linguistic transitions. But perhaps most remarkable was the discovery of what researchers called predictive phrasing, grammatical structures that specifically indicated forecast rather than record. Sumerian possessed different verbal aspects for describing events. Completed actions used one set of markers. Ongoing conditions used another. And expected future events used a third. When linguists analyzed omen texts with this framework, they found the majority of celestial warnings use future tense constructions, combined with conditional clauses, the grammatical structure of prediction, not history. A tablet from Nippur demonstrated this clearly. Mul.ge.tab kai dinanakumar u.7 kamer hull.gaq. Word by word, striking star when moon with crosses if day.7 and evil shall exist. Standard translation: when the striking star crosses the path of the moon, destruction shall fall in the 7th season. The grammar was unambiguous. This wasn't describing something that had happened. It was forecasting something that would happen when specific celestial conditions aligned. And the text provided those conditions with astronomical precision, the striking star appearing in conjunction with the moon during a particular phase, with the consequence manifesting in the 7th season, approximately 2 years later, allowing for delayed climate effects from atmospheric dust loading. When researchers checked modern astronomical catalogs, they found the only objects that could plausibly cross the path of the moon, while matching the Sumerian descriptions, were comets or large meteor stream fragments, passing through near-Earth space, exactly the type of objects in the Taurid complex. The Enuma Annuenlal contained dozens of such predictions, each using the same grammatical structures, each providing specific celestial configurations, each projecting consequences forward in time based on observed patterns. But one series of tablets took prediction to an extraordinary level. Known as the counting tablets for their heavy use of numerical sequences, these texts appear to calculate future risk windows by combining multiple celestial cycles, lunar nodes, Venus returns, solar year counts, and the precession of equinoxes. The mathematics were complex, requiring tracking dozens of variables across centuries. One tablet from Europe contained a calculation spanning 1,440 years, 40 complete cycles of the 36-year Venus-Jupiter conjunction, period apparently designed to identify when multiple risk factors would align simultaneously. The text concluded, in the completion of the count, when all paths cross, the fire shall return as it did in the time of the fathers before the waters. Before the waters was a consistent Sumerian reference point, their term for the pre-flood era, the time before the Younger Dryas deluge reshaped the world. The text was explicitly linking future predictions to that ancient catastrophe, suggesting the scribes understood they were tracking the same recurring phenomenon that had devastated their ancestors. Modern researchers attempting to verify the calculation found themselves stunned. When they projected the Sumerian count forward from the tablet's composition date, approximately 2400 BC, accounting for calendrical differences and the various celestial cycles being tracked, the calculation pointed to a risk window falling between 8,001,400 AD, the medieval warm period. Historical records from that era document unusual atmospheric phenomena, crop failures in multiple regions, and several recorded meteor events of unusual intensity. While no confirmed major impact occurred, astronomers now know Earth passed through a certain average region of the Taurid stream during that period. The Sumerian calculation had identified an actual elevated risk window 2,000 years before it arrived. Other counting tablets projected even further forward, with some calculations extending 3,600 years or more from their composition, placing their target windows in our current era or near future. The implications were difficult to ignore. The Sumerians hadn't just recorded past impacts. They had developed a predictive framework sophisticated enough to forecast future risk periods, based on the orbital mechanics of recurring debris streams. And they had encoded this knowledge in language designed to survive translation, ensuring that even if future generations lost the ability to read Sumerian, the essential warnings might persist in derived languages like Akkadian, which would eventually influence Hebrew, Arabic, and Greek astronomical terminology. The scribes had built a message system designed to outlast their civilization. But that raised the final, most unsettling question: if they succeeded, if their warnings did survive encoded in language, preserved in tablets, waiting for a future civilization advanced enough to understand them, were the Sumerians trying to record the timing of the next great strike? And if we finally learn to read those warnings correctly, to understand the cycles they tracked and the calculations they preserved, what exactly are those ancient voices telling us about the danger window we're entering now? The answer required bringing everything together, every fragment of evidence, every discipline, every piece of the puzzle that had been accumulating across more than a century of research. In 2018, a multinational team assembled specifically for this purpose: archaeologists, astronomers, geologists, linguists, and climatologists, specialists who normally worked in isolation, gathered at the University of Edinburgh to attempt something unprecedented: a comprehensive cross-disciplinary analysis of the Sumerian impact hypothesis. They called it the Mesopotamian Sky Threat Assessment Project. The team's approach was methodical. They compiled every relevant data point from their respective fields, then looked for correlations, places where independent lines of evidence converged on the same conclusions without prior coordination. The results were startling. When archaeoastronomers mapped every Sumerian temple alignment they could verify, a pattern emerged. The structures weren't randomly oriented toward aesthetically pleasing constellations. They pointed toward specific sky regions during specific times of year. And those times corresponded precisely with modern calculations of when Earth passes through the densest portions of the Taurid meteor stream. The ziggurats are aligned toward the Taurid radiant during late October, 3000 BC. The temple complex at Eridu oriented to track the same region during its heliacal rising, allowing priests to calculate exactly when Earth's orbit would carry it into the debris field. The observatory platform at Nippur designed with sight lines that framed the maximum danger window, providing visual confirmation when the risk period had arrived. These weren't religious choices. They were targeting solutions for a tracking problem. Meanwhile, linguists analyzing the Mulopin catalog noticed something remarkable. The periodicities recorded in the star tables, the cycles of when certain celestial events would repeat, matched modern astronomical data for Taurid stream density variations with extraordinary accuracy. The Sumerian texts recorded a major cycle of 3,600 years, close to the intensification period identified by Czech astronomers studying gravitational perturbations in the debris field. They documented a minor cycle of approximately 600 years, matching the observed clustering of historical impact events. And they tracked an annual cycle marking the dangerous seasons late October through November, precisely when the nighttime Taurid stream reaches maximum activity. The correlation wasn't approximate. It was exact. But the most compelling evidence came from the geological team. They had spent months analyzing sediment cores, ice samples, and soil deposits from across the Middle East, looking for impact proxies, the physical signatures left by cosmic catastrophes. What they found validated the timeline the Sumerians had preserved. In sediment layers dated to approximately 10,800 BC, the Younger Dryas boundary, they found the expected markers: nanodiamonds, spherules, elevated iridium. The impact event the Sumerians referenced as before the waters was geologically confirmed. In Akkadian era deposits around 2200 BC, the 4.2 kiloyear event, they found evidence of extreme heat events, atmospheric dust loading, and sudden climate shift. The collapse the tablets described as the season of darkness left physical scars in the earth. In Bronze Age layers around 1200 BC, the 3.2 kiloyear event, similar signatures appeared: cosmic dust, temperature drops, agricultural collapse. The geological record and the Sumerian astronomical records were telling the same story from different perspectives. But then the team made a discovery that elevated everything from interesting correlation to undeniable convergence. Using infrared satellite imaging technology that can detect subsurface anomalies invisible to normal observation, geologists scanned the Mesopotamian plain looking for impact structures. The region's frequent flooding and millennia of sediment deposition had buried the surface, but density differences from ancient impacts would still be detectable. They found over 40 circular anomalies consistent with explosive airburst events. Most were small evidence of objects that fragmented in the atmosphere, creating localized blast zones. But several were substantial, perfectly circular depressions between 500 and 2,000 meters in diameter, showing shock patterns, radial ejecta distributions, and compressed sediment layers. These weren't impact craters in the traditional sense. Most meteors never reach the surface intact. There were airburst signatures, the ghostly footprints left when massive objects exploded overhead, channeling their energy downward in a focused shockwave that left a characteristic circular scar. And when the team cross-referenced the locations and estimated ages of these features with Sumerian settlement patterns and textual references, they found matches. One anomaly near ancient Lagash corresponded with a tablet description of the day the wind came without clouds, and the city walls fell, though no enemy approached. Another near Ridu aligned with references to the burning cloud that needed no rain, and the fire that fell from heaven in the time of King Meskiagashur. A third, particularly large signature northwest of Uruk, matched the approximate date and location referenced in texts describing the stone that turned sand to glass and the river to steam. The mythology wasn't symbolic. It was eyewitness testimony preserved across millennia. When the climatology team added their data ice core samples showing elevated cosmic dust particles during the same periods, tree ring records indicating sudden cooling events, and pollen analysis revealing rapid vegetation die-offs, the picture became complete. Every independent line of evidence pointed to the same conclusion: Earth had experienced recurring cosmic impacts throughout the period of human civilization. These impacts followed predictable patterns linked to debris stream encounters. And the Sumerians had somehow identified and tracked those patterns with remarkable precision. The team published their findings in 2019. The paper's conclusion was measured but clear. The convergence of archaeological, astronomical, geological, linguistic, and climatological evidence suggests that Sumerian astronomical texts represent a sophisticated attempt to monitor and predict cosmic impact risk based on empirical observations spanning multiple millennia. The accuracy of their risk window identifications, when compared with modern torrid stream modeling, indicates a level of astronomical knowledge previously unattributed to Bronze Age civilizations. In academic language, it was as close to "they were right" as scholarship permits. But the paper's final section posed a question the research team couldn't answer. The Sumerian calculations projected forward as well as backward. Their counting tablets identified future risk windows based on the cycles they tracked. And when those projections are extended using modern astronomical understanding of the torrid complex behavior, several calculations point to elevated risk periods in the late 20th and early 21st centuries. Modern astronomers studying the torrid stream independently reached similar conclusions. Computer simulations showed Earth's orbit carrying us through increasingly dense regions of the debris field during this year. Not catastrophically dense, but significantly elevated compared to recent centuries. The risk isn't absolute. Most objects in the stream are small. Many years pass without incident. But the probability curve has shifted. We're entering one of those periodic windows the Sumerians spent millennia learning to recognize. And we're entering it largely unaware, without the institutional skywatching infrastructure they built, without the multi-generational observational programs they maintained, without the cultural memory that kept their civilization alert to a danger most modern people don't realize exists. They tracked these cycles because they understood what we're only beginning to relearn: impact events aren't random cosmic accidents scattered evenly across deep time. They cluster in periods driven by orbital mechanics, creating windows of elevated risk that return with predictable regularity. We happen to be living in one of those windows. If the ancients truly recorded cycles of cosmic danger, if their calculations accurately identified the patterns we're now confirming with modern astronomy, if their warnings were meant to reach across time to civilizations that would eventually possess the technology to understand them, what cycle are we living in right now? And more urgently, are we prepared for what the Sumerians spent 3,000 years trying to warn us about? In 2022, NASA's Planetary Defense Coordination Office released a quiet update to their near-Earth object threat assessment. The analysis confirmed what independent astronomers have been tracking for years: between 2030 and 2040, Earth's orbit will carry us through the densest concentration of the torrid meteor stream encountered in over 2 centuries. The timing matches Sumerian projections with unsettling precision. Their tablets described the return of the fiery stones during a period when multiple celestial cycles converged. The same convergence modern calculations show occurring within the next 2 decades. They warned of the crossing of the red star and the season when the heavens grow hot, using the future tense, projecting forward through millennia to mark this exact window. Their texts don't describe the past. They describe a recurring threat, one they had witnessed before and calculated would return. The Sumerians weren't just looking backward, preserving the memory of ancient catastrophes. They were looking forward, building a warning system designed to reach across time to whoever would eventually inherit the sky they had watched with such intensity. They were trying to warn us. Every temple alignment, every astronomical calculation, every carefully preserved tablet was a message sent forward through the centuries: the sky can betray you. The danger follows patterns. And the patterns return. We are the civilization they were writing to, the ones living in the age when their counts would reach completion, when the cycles would align again, when the question wouldn't be whether the danger exists, but whether we remembered enough to see it coming. So, as you drift toward sleep tonight, somewhere between dream and history, consider the ancient scribes pressing warnings into wet clay by lamplight, knowing they would never see the future they were trying to protect, trusting that someone, someday, would finally understand what they had spent lifetimes learning to recognize. If the Sumerians recorded the last great impact before it happened, are we now living in the age they feared would come again?